now we move to our last presentation, but not least. So Ana Oliveira is going to talk about it. I mean, the communication with the stakeholders, and she will cover this perspective. So Ana, she is an Earth observation researcher specializing in machine learning-based applications for climate change, hazard mapping, and impact assessment at CoLAB Atlantic. I think I pronounced it properly. I don't know. Then you correct me. She has been working on the climate application, focusing on atmospheric and ocean heat waves, being the technical lead in several activities, including European Space Agency projects, focusing on marine heat waves impacts on agriculture, among others. And she's also a science team member of GRACE since 2023. So Anna, welcome, and the floor is yours. You can share your...
Hello.
Hi.
Hi. Let me just include the sound because I have some sound for you as well. Okay, hope you are seeing my screen now, right?
Yeah, we have it.
Let me just put your faces here so I can look at the others. Hi, hello, good afternoon, everyone. So first of all, thank you for the invite, Christina, Erika, Chiara, and all the organization. I'm very glad to be here. I will start to make a humble acknowledgement that I'm not an oceanographer, nor have I experience in working on ocean and marine applications, except for the last 2 to 3 years. So bear with me if I make any mishap in terms of the wording of certain aspects, some physical events, etc., physical variables and scientific words, let's say. So going ahead with my presentation. So as Christina said, my name is Ana Oliveira. I'm representing here CoLAB Atlantic, in particularly our involvement in 3 projects, CARE, HEAT, and MITU, funded by ESA. These are part of the Ocean Health Cluster that was presented by ESA a couple of minutes ago, and also the Off-Sea for Clean that Chiara already mentioned. It's an Horizon project that is just kickstarted, and our participation in both in the 3 projects is related to marine heat waves and their impacts. So as discussed before, the CARE HEAT project, along with the MITU, are projects related to mapping the hazards themselves, but also the impacts. These are ESA-funded projects that aim to advance the scientific underlying assumptions that we have related to these extreme hazards. CARE HEAT is focused on marine heat waves, and MITU is focused on multiple hazards when they could occur together. So marine heat waves with hypoxia, for instance. And then on Off-Sea for Clean, we have more like a large-scale overview of marine heat waves in the sense that we want to advance the observation framework in the framework of WMO's ECVs and also UVs. So we want to derive from our activities on other activities that are going to be pursued the specific requirements, scientific requirements, but also user requirements for such essential climate variables to surveil this kind of events. So when I was challenged to this presentation, I tried to make up 3, 4 actions which I would like to propose for the community to move forward with this kind of climate applications. And this is not specific to marine heat waves, but I think marine heat waves are here more of an example of these actions. So one of the things that I've been seeing recently in climate research and marine heat waves in particularly is the need to consolidate definitions. So when we talk about marine heat waves, we are talking about persistent extreme events, and like the atmospheric heat waves, there is no broad consensus on the definition because certain research groups each produces its own algorithm. Sometimes they use different reference periods, sometimes they use fixed or moved windows of climatology, and all of these aspects are very relevant whenever we try to measure an extreme value. For instance, in the scope of the off-day definition, this in terms of marine heat waves is probably the one that is more frequently used. We are talking about using a 30-year period of reference for the climatology. Then we establish the 90th percentile, and we define a marine heat wave whenever we have 5 consecutive days surpassing this percentile. Then the marine heat wave intensity itself, which is a measure of the sizable of the marine heat wave, it's the difference between this absolute temperature and the climatology mean. This is a bit different than atmospheric heat waves, in which the intensity is between the reference threshold and the maximum temperatures. Here it's related to the mean. This is because the amplitude of the temperature in the sea surface is lower compared to the atmosphere. But despite this being one of the most consensual definitions, the fact is that we are talking about a non-stationary system. And by non-stationary, I mean that we are seeing climate change and we are seeing long-term trends. So how can we measure something that we point forward as an extreme whenever our baseline is evolving? This is something that was studied in the CareHeat project, and I'm hopeful that OPSI4Clim can take advances out of this as well, because the researchers there, and I'm not personally involved in this climatology study, but I'm here to, presenting the outcomes of the project itself. So looking at the Mediterranean as an example.
We have one of the co-authors here. We have the co-authors of this work here, yeah, and this is from ICM.
Yeah.
Go ahead.
Yeah, good. So maybe I test the words. No kidding.
No one to put pressure.
No pressure, no peer pressure, no whatsoever. Yeah, so part of the results of the project is that they proved, if you look at the probability density functions on the right-hand side, you see the red PDFs are the most recent 2 decades, and the blue ones are the oldest 2 decades, and the black is the mid. And what you see is that the probability density function is actually moving to the right-hand side. And this is tied to the global underlying linear trend of climate change, which means that the extremes are not being larger towards the mean. So we are not seeing an amplitude of values, we are just seeing a shift. This is what they did for the Mediterranean, and it's one of the outcomes of the project. It does not mean that it's the same in every basin, but it's still a very meaningful result, because it means that we have to make like this sensitivity analysis of the reference period that we use. And this is another part of the same study in which we have the detrended time series compared to the trended one, and where you can see that whenever we say that marine heat waves are increasing, that is based on the assumption that the climatology used is a fixed one. If we move the climatology along with the trend, we will cease to see this increase, at least in the Mediterranean. So the point from this result of CareHeat is basically that the definitions have to be consolidated. And I'm hopeful that you can also look at the Marine Heat Wave Atlas. You already have available the non-detrended one. The detrended one is going to be shared hopefully in the next few months. And I'm hopeful also that in OPSI4Clim we will further use this and also do more sensitivity analysis to try to provide to the community a more consensual definition of marine heat waves. Then the second action I would see that has to be implemented is to consistently support forecasting services. And for this, we would need base funding, we would need consistent and permanent reliable funding to ensure that the entities involved in forecasting services are well supported, because otherwise, purely on a project-based forecasting, it's difficult to have the services beyond the lifespan of the project. And here is an example of things that we have been doing also, and we hope to advance this specifically in OPSI4Clim, which is the relationship between the atmospheric climate modes on the Atlantic and how they impact marine heat waves on the Atlantic as well. So here you have 2 examples. In this first example that you are seeing here, you see marine heat waves spreading mostly in the northern part, and we are talking about a North Atlantic oscillation negative mode. And this that you see here is the marine heat wave spreading in the polar region. And this that you see here in red and blue colors is an animation of the centers of higher and low pressure. And as probably you know even better than me, when you have a negative mode, you have a wobbling jet stream. And this means that high pressure and low pressure centers move up and down in latitude, and this potentiates the development of heat accumulation in the highest latitudes. By contrast, when you have a positive North Atlantic oscillation mode, and this is another example from 2018, you can see that you have a more persistent anomaly of mean surface level pressure in mid-latitudes, and this is along the Portugal latitudes in particularly. And you can see the marinite waves concentrating in these latitudes and developing as we go towards the summer, let's say. You also see some increase in marinite waves here in the Mediterranean, although it's not fully covered in this image. So this was the second action. Now the third one. The third one is more about impact assessment. So our role in CareHit and Me2, as we work with the remaining project partners, is to establish meaningful impact assessments. And the first question when we do this is to make sure that the user is listening and is listening properly. So what we did is to study aquaculture impact assessment in marine protected areas. I'm specifically presenting the aquaculture ones because it's the one we have been leading. And what we did in the first stage of the project was to produce a questionnaire. But because questionnaires, as you probably know, are very hard to ensure that we have responses, we try to have bilateral discussions with them and to design a set of user stories that could be deployed for, let's say, a surveillance operational marinite wave service afterwards that is fit for the purpose of their application. So 3 examples here. A nearshore seaweed aquaculture farmer in Norway, this is a real one, wants to estimate biomass growth. And they want to do it because they want to estimate when to harvest the kelp, and they want to plan ahead how many cycles of harvesting and deployment they will have in certain years as a function of climate conditions. We have another example from Portugal, in which a bivalve aquaculture farm in Ria Formosa, this is like a coastal area in Olhão, so Algarve, the southern part of Portugal, wants to evaluate the economic impact of marinite waves on the energy costs because they need to control for the temperature of the recirculation mode, and this has an impact on their energy consumption to ensure regular temperature in their production. And a third example is from a sea bream aquaculture farmer in Madeira, which is another one also involved on CareHit as a final user. And these guys, they want to better predict fish growth cycle in the long term. So we are talking between years and seasons. And the reason why they do that is because they want to restock the juveniles month ahead. So they want to understand how long does it take from buying the juveniles, deploy them in the cages, and then harvest them, because they want to buy and take advantage of the prices of the juveniles pretty much in advance. So these are certain, well, I'm going to jump this one because otherwise I will take longer. So things that we ask them, whether they want long-term or short-term climatology information, whether they want point data or high-resolution geospatial data. And it seems that these users are more interested in accurate and site-specific time series of data, even if it's forecasting, and not as much in geospatial data services. And this is very relevant because whenever we talk about generalization of the predictions, we often have to make a compromise between spatial resolution and accuracy. And these producers, they seem to be more worried about the accuracy and not having the spatial dimension instead of having maps, for instance. This is useful for making the transition between meta-ocean predictions towards the final users. And finally, or almost finally, I have an example of the impacts. So I'm assuming a lot of scientists are there in the audience. And of course, these regressions, if you look at them, they have very few points, but these are very meaningful to us because it's all that we got. This is the first. So users are not willing to share their impact data, and without their data, we cannot account for the impact itself. But one thing that we learned from the Madeira users is that they often said that marinite waves are a good thing because they are growing sea bream in Madeira, and the water is cooler there compared to the Mediterranean, for instance. So they say that marinite waves are a good thing for them. But as we kept the dialogue open and we have regular meetings with them, we showed to them these plots. And what you see from these plots is that, yeah, we might see a negative correlation with that ST mean, as you can see. You can see my pointer, my mouse.
Yeah.
In this one, although it's non-significant and not significative, you also see this one, which is also, not very interesting. Also this one. So this is the growth cycle, the number of days that it takes from the fish from juvenile up to harvest or to get out of the cage to be sold. But this one is the one most interesting. You can see here a correlation of 0.4. I know it's not brilliant. I know the points are not brilliant as well in terms of the amount, but it's what they've offered us. We don't have more. But I think we can see a trend here, and we see a trend that the growth cycle of the fish tends to be larger, and this is a bad thing for them. So it takes more time to go from 5 grams, which is the weight of the fish of the juveniles, up to reaching the approximately between 400 and 500 grams. That it's their target weight, final weight, as a function of marinate waves. And as we kept the dialogue open, what we find out is that for them, marinate waves is actually when absolute temperatures of the ocean are larger. So for them, it's a synonym, and it's not. We had to have like 2 or 3 talks to them for them to finally get that marinate waves is an anomaly and it's a relative measure of deviation. And because it's relative, you can have actually marinate waves in the winter. And as we kept the dialogue open, we now are at a stage in which we suspect, I don't have data to support this yet, but we suspect, based on their feedback, because it's their suspicion, not ours, that what explains this plot here and this kind of trend is the fact that they have this kind of diseases going from October up until to December. And it seems that they are probably more probable during warmer winters, but they were not receptive to having negative impacts from marinate waves because from their preconception, marinate waves were only during the summer in larger SSTs. So they were not accounting for winter or autumn marinate waves, which is when you have a positive deviation during the colder season. So stay tuned for more findings because this is still an open question. And finally, I will leave you with a video. I will share it also here in the chat. But I think from the citizen perspective, you have to make people feel something, otherwise they will not act. And because of this, many of you already seen this. We did a video using machine learning to translate marinate wave trends, so the data itself, towards a musical interpretation. This is not exactly music, it's more like sound interpretation or sonification. And I'll leave you here with the video that has, it's only a part of the video because it's too long, but I felt it would make a very good conclusion to this. So